Hello everyone. Today we are going to discuss about a new chapter which is computational thinking and programming. First of all, let's dig in. What is the meaning of computational thinking and programming? Basically, computational thinking means a problem solving skill that involves breaking down complex problems or else situations into manageable chunks. So, basically, manageable pieces. So, this is a key skill when it comes to the programming language, basically, computer programming language. And now, let's see what do you mean by programming. I will take an example to explain you this in better way. Let's take an example. Imagine that you are building a house. Just think what are the materials you want. You want bricks, you want cement, and maybe some metals and some sand. Likewise, they are the materials that you are using to build a house. Have you ever thought what are the materials or how these softwares are made? Softwares means in the day-to-day life, the normal applications you are using on your computer or else on your smartphone or else on your tablet device. So it can be anything. It can be the PowerPoint presentations which I am showing you right now, and Microsoft Excel, Microsoft Word, or else Uber Eats app on your mobile phone, or else Facebook application on your mobile phone. Have you ever thought how these things are made of? Actually, these things are made of programming languages. So these are like made of with codes, and which you can see some example on the left side of this PowerPoint slide. So these are the things that we called as computer programming. So start with the computer programming, we need to learn the basics. So today we are going to learn the basics of computational thinking and programming. So let's go to the lesson today. First of all, let's see what are algorithms. Okay, so algorithm means a set of instructions or steps that helps you to perform a specific task or maybe solve some problems. For example, let's see going to school. Let's see what are the steps that you are following when it comes to going to school. First of all, you need to wake up early in the morning, and then you jump out from the bed, and then you brush your teeth, have a wash, and get ready with your school uniform, then have your breakfast, and after that you go to school. What if you have missed any of these steps? For example, imagine you have missed having your breakfast. Okay, still you can go to school, right? But at school you must be feeling very starving, right? So that means all the steps that we are following to reach the school are really important. So algorithms are like that. So when it comes to the computer language, if you are going to solve a problem or to perform a specific task, there are set of step by step instructions designed to perform a specific task or a particular problem. So those are the things we called as algorithms. So now let's see what are the ways of algorithms can be represented. First one, flowcharts, then pseudocode, then written stories, and after that programming codes, decision tables, and finally Nash-Schneiderman diagrams, or else we call them as NSDs. So let's take a look at these things separately. Okay, first we will talk about flowcharts. Flowchart means a graphical way of representing algorithms in very understandable way. So using this method, users can easily identify how the data is flowing until a specific problem or a task is completed. So if we take a look at the definition, a flowchart is a graphical representation of an algorithm using symbols representing different actions or steps. So when we are drawing or creating flowcharts, there are some standard symbols in flowchart. So let's see first what are they. First one, the oval shape. This oval shape stands for representing the start and end process of a flowchart. When you are drawing a flowchart, first of all you need to start, and then finally you have to stop the process at when it comes to the uh, process is completed or the problem is solved. So that representation is made by oval shape, and that is for start and end process. And then let's see the rectangle. The rectangle denotes a process of operation steps, and then the arrow. So the arrow is indicating the flow between the steps. So when you are drawing a flow chart, make sure all the steps are connected using arrows. And then a diamond shape. Diamond shape signifies a point where a decision should be made, and that decision should be uh, uh, based on yes or no. So basically, for example, if you take you are going to school, and sometimes you might get late, so you might take a decision sometime. Either you are having breakfast, or else you pack it and take it to your school. So that's a decision. So those decisions are represented by this diamond shape. And finally, parallelogram. So this parallelogram is used to input or output operations. So these are the standard symbols when it comes to drawing flowcharts. Let's see the next method of creating visually representing the algorithm step. Variables. Now let's see what are variables. For example, variables are the fundamental concepts that serve as containers of storing data values. So, in simple terms, variable is a data that has a value. For example, your age. So that's a variable, and maybe your account balance that can be a that has a value. So that's a variable. So those are the things we consider as variables in computer language. So basically, a data which contains some value are considered as variable. So let's see some real world examples for variables. As I said, student age in school database, your age can be a variable. If you are in age 10, age 11, or age 12 years old, that age can be a variable. And next, temperature. If you are using smartphones or laptops, you must have seen it's showing the weather every day, right? So you are seeing the number of degrees currently it's having today. It can be 30 degrees, 35 degrees, so likewise. So that means that temperature has a value. So that value means it's a variable. So that is another example that I can give you. And then bank account balance. For example, let's say you must be having a bank account, then that bank account is having some money. And example, let's say 10,000 rupees, 20,000 rupees. So that means that's a value, and that's a variable in terms of computer language. And this graph shows how the variables are derived, and variables are into two different groups: qualitative and quantitative. So the qualitative are further separated as nominal and ordinal, and the quantitative variables are further described as discrete and continuous. So these things I will explain you in future lessons. So these are the examples you can take for the variable sub.